See the question here, students. 6.10 from your book bag exercise. This question actually appears to be tough, but actually it is not. You have to first understand the question, okay, slowly, then only and clearly, okay, then only you can solve these kind of questions. See, calculate the enthalpy change on freezing of 1 mole of water at 10 degrees Celsius to ice to minus 10 degrees Celsius, okay, and the enthalpy of fusion value is given and some data have been given, okay. So first clearly understand what they have asked and what they have given. See, there is a system, okay, there is a system of water, okay, so this is a liquid water. At what temperature it is 1 mole of water, okay, so it is 1 mole of water. At what temperature it is 10 degrees Celsius, okay. They are asking the enthalpy change involved, okay, to convert this water into ice, okay, so it is now solid in nature, okay. At what temperature? 10 degrees Celsius. So to convert the water at 10 degrees Celsius to the ice at minus 10 degrees Celsius, find the enthalpy, okay. So please don't confuse yourself. So I will clearly explain how to solve this. See, the enthalpy involved in this entire conversion is, okay, so you have a liquid water, so this is 1 mole, okay, each and everything is 1 mole, no doubt about this. So first at 10 degrees Celsius water, you have to bring that water to 0 degrees Celsius, okay. So here one enthalpy will be involved, okay. Then to convert this water into ice, so ice at 0 degrees Celsius, okay. So here one enthalpy is involved. Then you have to convert, okay, bring this ice at 0 degrees Celsius to minus 10 degrees Celsius. So there are 3 enthalpies involved, okay. So how to solve this step by step, I will tell you. So first calculate the del H1, okay. So del H1, see, for this the datas have been given, I already told you. So this takes place at constant pressure, so you can use this, okay, Cp del T. So your Qp is what? Del H, okay, I already told you del H is equal to Qp. So del H1 is nothing but Cp into del T, okay. So for this Cp of water, the heat capacity at constant pressure for the liquid water is given, okay. So the liquid water, so here the temperature changes from, okay, 10 degrees Celsius to 0 degrees Celsius. So this is your T1 and this is your T2, isn't it? Your del T is what? T2 minus T1. So your Cp is 75.3, okay, into what is T2? T2 is 0 degrees Celsius minus 10 degrees Celsius, okay. So your answer is 75, okay, 753, okay. This is joules per mole per Kelvin. So you have found out del H1, okay. So now what is it? Your del H2. See students, del H2, the liquid water at 0 degrees Celsius is converting to ice at 0 degrees Celsius. See this data, okay, this data, enthalpy of fusion is given, okay. Enthalpy of fusion normally means the reverse. The ice is converting to liquid water, and this we call it as fusion. The ice converting to liquid, we call it as fusion. The enthalpy of fusion is 6.03 kilojoules per mole, okay. So here what happens here? See, the reverse is going to happen. Liquid to ice at 0 degrees Celsius. So it is the reverse of enthalpy of fusion, isn't it? So the value here is minus 6.03 kilojoules per mole. You understood, students? So ice to liquid is enthalpy of fusion, its value is given here. Liquid to ice at 0 degrees Celsius, okay. So it is a reverse of, so I'm reversing the value, okay. It is a thermodynamic property, isn't it? So your del H2 is nothing but 6.03. See here the value is in kilojoules per mole, okay. So it is in joules per mole, it is in kilojoules per mole, okay. So to convert this. So what we can do, we can convert this into joules. So instead, so minus 0.753 kilojoules per mole per Kelvin. So the remaining thing what we have to solve is only the third enthalpy change. So here also ice is converting to ice, only the temperature is differing. Okay, here liquid to ice, liquid to solid. Okay, so here the same thing only, but temperature only differs. So we are going to use the formula Cp del T. Okay, so here this is the T1 here and this is the T2 here, and here the enthalpy the heat capacity of ice is given. Okay, so use that. So here, so 36.8, what is T2? T2 is minus 10 minus T1. T1 is 0 degree Celsius. Okay, so the answer is 36.8 minus 36.8 joules per mole per Kelvin. And if you convert this into so here convert this into kilojoules. So here it is. Okay, so the total enthalpy involved is equal to del H1 plus del H2 plus del H3, isn't it? So bring all the values here. So minus 0.753. So if you do these kind of problems, make sure the kilojoules and joules, everything, okay, all are in same units. Okay, so if you sum it up, your final answer is minus 7.151 kilojoules per mole. Okay, students, so I'll meet you in my upcoming videos with the remaining concepts. Okay, thanks for watching.